Hey class, in today's lesson we're going to talk about solving rational equations, which is found in section 8-6 of your book. We are going to obviously solve rational equations. Alright, so first of all you need to know that a rational equation contains at least one rational expression, which means that rational, remember ratio, that means division, but it has to be an expression such as a polynomial expression. So the first example actually has quite a few rational expressions, and the non-example does not have one at all. Had this first term where the x is, had that term been over some type of polynomial, that would have been considered a rational equation, but it's not at this time. All right, so in example one, it kind of got cut off here and I didn't really feel like typing it, but it says what are the solutions of the rational equation? Okay, so we have x over x minus 3 plus x over x plus 3 equals 2 over x squared minus 9. Okay, remember we need to have everything in factored form, so this needs to really be 2 over x plus 3 and x minus 3. All right, with that being said, we need to go ahead and multiply. We need a common denominator. If we get a common denominator, then we can essentially get rid of the denominators at this point. We can only do this with equations, not with expressions that we've dealt with before, like adding and subtracting, multiplying, and dividing. But when you have an equation, once you have a common denominator, you can essentially get rid of it. All right, so what we're going to do is multiply every fraction by what it's missing. So first of all, let's state our LCD. And our LCD is going to be x plus 3, x minus 3. All right, so this first one is obviously missing x plus 3 over x plus 3. This second one is missing x minus 3 over x minus 3. And the last one is missing none. So now that they all have the same denominator, we can cross out the denominators and just look at the numerator. All right, so when I rewrite the first numerator, that's x times x plus 3 plus x times x minus 3 equal to 2. Okay, now we're going to distribute. So if we distribute here, we'll get x squared plus 3x. And if we distribute here, that's going to be x squared minus 3x equal to 2. At this point, I can see I have an x squared. Let's just keep going. We will have 2, well, those go away. So it's going to be 2x squared equal to 2, divide by 2. And x squared is going to be equal to 1. And we should know at this point, if we take the square root, that x will equal plus or minus 1. And so those are our solutions. All right, so again, in example 1, you just want to be sure, and actually in any of the rational equations, you want to factor as far as you can, and then determine what the least common denominator is, multiply those fractions by what they're missing, and then once all the denominators are the same, you can cancel out the denominators. Alright, so in this next example, again, we first need to rewrite the first denominator as x plus 1 and x plus 2. Alright, with that being said, we need to multiply by, well, first of all, we need to find our LCD. Hopefully, by looking, we should be able to see that the LCD is x plus 1 and x plus 2. So this first, or the second fraction is missing an x plus 1. And this last fraction is missing an x plus 2. Alright, with that being said, we need to go ahead and get rid of the denominators. And so when I start rewriting it, I get x minus 1 plus 2x times x plus 1 equal to x minus 1 times x plus 2. Alright, so we need to start rewriting. So x minus 1, if I multiply the 2x for those, I get plus 2x squared plus 2x. If I keep going, I'm going to make a box for this one. Remember, because a binomial times a binomial, we can use this box for our polynomials. So that's x squared, 2x, negative x, and negative 2. So that will give us x squared plus x minus 2. I'm going to continue to simplify on the left-hand side, so that will be 2x squared. If I combine x, right, and 2x, that'll give me 3x. and then minus 1 equal to x squared plus x minus 2. At this time, you should recognize that you have a quadratic equation on the left and a quadratic equation on the right. So in order to solve for x, we need to move everything to one side, and I'm going to move everything to the left. So to do that, I'm going to subtract x squared, subtract x, and add 2. That side will now equal 0, and this will be x squared plus 2x plus 1. Now at this point we should see that the factors, the AC is 1, and the factors of 1 that give you 2 are going to be x plus 1 and x plus 1. So x is going to equal negative 1. Alright, so this is something new that we also need to talk about. Yes, algebraically, we found that x equals negative 1. Okay? However, this equation actually has no solution. And the reason being is because x equals negative 1 is a new word that we're going to learn. It's called an extraneous solution. Okay, and so basically what that means is, and how we can tell that we've gotten an extraneous solution, is that the original equation, if in your original equation, in your denominator, when you set any of those denominators equal to 0, if you get x equals negative 1 in this example, then it's an extraneous solution. So for example, we found out from the very beginning that right here where we see x plus 1, right? That x plus 1, had I set that one in particular equal to 0, I would have gotten x equals negative 1. Well, there's no way that x equals negative 1 can be a solution, because if I plug it in right there, I would get negative 1 minus 1 as the numerator over negative 1 plus 1, which really is negative 2 over 0, but that's undefined. So because negative 1 cannot fit as a solution into just even one of the factors of the denominator, then in this case we have an extraneous solution, so there is no solution here. Now, just because something is extraneous does not mean that your problem will not have a solution. It's just that there was one x found, and that one x happened to be extraneous. So because that was our only option, that's why it's no solution. It's very possible to have an extraneous solution and an actual solution. Okay, so let's keep moving. Alright, so once again, guys, we are going to find our least common denominator, and our LCD here, there's only one option, so it's x plus 2. Guys, what we should recognize is we don't need to multiply by anything because these denominators are already set. So technically, it's kind of a trick problem. These are gone, right? Because that's the same thing as saying, for example, 4 over 1 equals 4 over 1. That's the same thing as saying 4 over 4. So we don't need to see the denominators because they are the exact same. Alright, so if I keep going, this will be x minus 1 equal to x squared plus 2x minus 3. Okay, let's move everything the same size. So subtract x and add 1. Subtract x and add 1. So we get 0 equals x squared plus x minus 2. AC would give you negative 2. The factors of negative 2 are 1 and 2. And the only way we're going to get a positive 1 is if this is positive 2 and negative 1. So x plus 2 and x minus 1. And if I set those equal to 0, I would get x equals negative 2 and x equals 1. Now here's the deal. X equals negative 2. Okay, sorry, let me go ahead and say it again. Negative 2 will be extraneous. So then that really leaves as a solution x equals 1, but you will always write both. So x equals negative 2 is extraneous, and then x equals 1 is actually the solution for this problem. All right, let's keep going. All right, so again, we want to find our least common denominator. So our LCD here is going to be x plus 1 and x plus 4. They are the unique factors of these problems, of these fractions. And on top of that, they are shown in each fraction at most one time. So we're going to multiply this first one by x plus 4. We're going to multiply this one by x plus 1. And the last one again by x plus 1. So that all the denominators are now x plus 1, x plus 4. So since that's the case, we're going to get rid of all the denominators. And so that leaves us with x times x plus 4 plus 3 times x plus 1 equals x plus 3 times x plus 1. If I distribute the x, that will give me x squared plus 4x. If I distribute the 3, that gives me 3x plus 3. If I put this last one in a box, because it's a binomial times a binomial, that's x squared, x, 3x, and 3. So that's x squared plus 4x plus 3. Once again, we need to move everything to one side, but I'm going to go ahead and simplify the left side first. Alright, so now I will subtract x squared, subtract 4x, and subtract 3. Alright, so what we'll see is that the x squareds are gone, so this is going to be 3x equal to 0. And so if I divide by 3, x will equal 0. X will be the only solution, x equals 0 will be the only solution for this problem. Alright, let's keep working. Alright, so this is example 2, our word problem. This is actually for the pre-AP students. If you are not pre-AP, you are more than welcome to skip on to the next example. Unless you're curious about what we're doing, then you can go ahead and watch this. But here we go. It says a flight across the U.S. takes longer east to west than it does west to east. It says assume that winds are constant in the eastward direction. When flying westward, the headwind decreases the airplane speed. When flying eastward, the tailwind increases its speed. The time for the round trip from Chicago to San Francisco, which is 1,850 miles, is 7 3/4 hours. If the airplane cruises at 400 miles per hour in still air, what is the speed of the wind? Alright, so we need to go ahead and set a variable for this problem, and the variable, let me go ahead and stop this really quickly. The variable for this problem, the variable for this problem is going to be x. Very simple, right? And x is going to be represented by the speed of the wind. Okay? So with that being said, they've also given us time. So let's think about that. If they've given us time and they've given us a rate, what's nice about this is that, and they're asking us for a speed, we need to go ahead and set everything in terms of time. So our total time is going to be equal to our time west to east plus our time east to west. So like I mentioned, we're talking about time, we're talking about speed, and we have miles, which is actually a distance. So we should recognize that we need to use a distance formula. But since we're putting everything in terms of time, we need to divide everything or both sides by r. So time is actually going to be equal to the distance over the rate. So here's the deal. Let's go back through our problem. It says when flying westward. So if I'm flying westward, that's actually, I'm flying westward, that's really east to west, right? And if I'm flying eastward, that is west to east. All right, those details are really important when it comes to our rate. All right, so our total time, which is 7.75, is going to be equal to the distance, which is 1,850, over the rate. And our rate is that 480 miles per hour. But you have to understand that as being that speed of the plane is also has to you also have to take into account the speed of the wind itself. So we have the plane and its own speed plus the speed of the wind. So we have 480. And since we're going westward, remember what it said about going west to east. West to east, which is flying eastward, increases the speed. So that's plus x. Okay. Plus east to west. Well, the distance is still the same. It's still 1,850 miles over and in this case, since we're going east to west, that's flying westward, and so it decreases the airplane speed. So that's 480 minus x. All right, now with all of that being said, we now need to go ahead and solve for x. And so our least common denominator here is pretty obvious. It's 480 plus x and 480 minus x. So this first one is going to be multiplied by and 480 minus x. Sorry, that's messy, but I couldn't really fit it in here. This one needs to be multiplied by 480 minus x. And this last one needs to be multiplied by 480 plus x. All right, this is getting a little messy, so what I'm going to do is start rewriting this on the second screen. All right, so let's go back. We said 7.75 was the total time plus, is equal to our distance, which is 1,850 miles over 480 plus x, plus 1,850 over 480 minus x. All right, with this first one, we are multiplying by two of them. We're multiplying by 480 plus x and 480, that's an 80, minus x. Okay, this one is 480 minus x. And this one is 480 plus x. All right, now with that being said, all the denominators should be the same, so I can cancel out all the denominators. So when I rewrite this first one, that would be 7.75 times 480 plus x times 480 minus x equal to 1,850 times 480 minus x plus 1,850 times 480 plus x. Okay, the most difficult one is going to be this first one, because it's a binomial times a binomial, so I'm going to do that work to the side. So 480 and x, 480 and negative x. All right, so let me pull out my calculator. 480 times 480 is 230,000. I made the boxes way too small. 230,400. These center boxes, this will be negative 480x and 480x. Those obviously are going to cancel. And then the last one is negative x squared. So this is really 7.75 times 230,400 minus x squared. Okay, and I'm not even going to write the next line like those. because now we're just going to go ahead and start multiplying. So we're going to go ahead and distribute 7.75 to both those. So 7.75 times 230,400 is going to give us 1,785,600 minus 7.75x squared. That's going to be equal to, now we need to distribute those, 1,850 times 480 is going to be equal to 888,000 minus 1850x plus again 880,000 or 888,000, sorry, plus 1850x. Okay, obviously those are going to go away. 888,000, two of them will equal, let's go ahead and write this, 1,776,000. Okay, and this is still 1,785,600 minus 775 x squared. All right, I'm going to try and isolate x at this point. So I want to get x by itself, so I'm going to subtract 1,785,600 on both sides. So it gives me negative 7.75 x squared equal to, let's see, 1776. It's going to give me negative 9,600. If I divide both sides by negative 7.75, then x squared is going to equal let's say 1,238.71, and then we know we're going to need to take the square root of that. So x is going to be about let's see, take the square root of that. About 35. So the speed of the wind will be about plus or minus. Technically, it's plus or minus 35, but really we know that speed is not going to be negative, and we could check that by basically putting positive 35 back into this whole equation. But just know that really x equals 35. And so that is our answer. So we did a lot of work, but we got everything we needed. So we are going to try one more problem, or another problem. All right, it says you ride your bike to the store 4 miles away to pick up things for dinner. When there is no wind, you ride at 10 miles per hour. Today, your trip to the store and back took 1 hour. What was the speed of the wind today? All right, so with that being said, remember, we're going to set this in terms of time. So time is going to equal the time to the store plus from the store. And remember, distance equals rate times time, but we're going to put everything in terms of time. So time will equal the distance over the rate. So our total time is 1 hour. To the store, the distance is 4 miles. Over the rate is 10. Here in this case, they're not telling us which one is headwind or tailwind, so we're just going to place them where we feel. Also because the distance is the same. All right, so 10 plus x plus 4 over 10 minus x. So once again, it's kind of obvious to see that our LCD is going to be 10 plus x and 10 minus x. So I need to multiply this first one by 10 plus x and 10 minus x. Okay, the second one by 10 minus x, and this last one by 10 plus x. All right, so now the denominators are gone. So I get 10 plus x times 10 minus x equal to 4 times 10 minus x plus 4 times 10 plus x. Okay, let's do a box for this first one. 10 plus x, 10 minus x, so that's 100, negative 10x, 10x, negative x squared. Those are gone, so that's 100 minus x squared. And if I distribute those, this is 40 minus 4x, and this is still 40 plus 4x. The 4x's are, the 4x's are gone. So we are left with, and let's go ahead and, let's see, 100 minus x squared equals 80. If we subtract 100, we will get, and I'm going to move it over here, we will get that negative x squared equals negative 20. Let's go ahead and divide by negative 1. So x squared now equals 20. If I take the square root of that, and we have to have a positive answer here, even though our answer is going to be plus or minus. Let's see. Plus, what's the square root of 20? Is about 4.47. Miles per hour is the speed of the wind, but really we know it's going to be positive 4.47 miles per hour. And we are done. All right, let's move on to the next problem. All right, lastly, excuse me, with example 3, we are going to use a graphing calculator. This is actually going to be very simple to do, actually. We are essentially going to put everything on one side in our calculator. We have to be sure that we use brackets and parentheses as necessary. And then we just type it in. So what we're going to do first by hand is to subtract 1 on both sides. So you will have 2 over x plus 2 plus x over x minus 2 minus 1 equal to 0. Now let me show you how you'll put this in parentheses. You'll have a parentheses where I'm placing these brackets, and then you'll have a parentheses, let's see, made a mistake, sorry. You're going to have, let's see, well, you're going to have parentheses around each of those, and then that should be all you need. That should be it. So I'm going to talk it through as we type it in. So you need 1 parentheses for the brackets, 1 parentheses for the first fraction, 2 divided by, and actually I lied. You do need another set just around your denominators. So 2 divided by parentheses x plus 2. Close it for just the denominator, close it for that fraction, okay? Plus, open it up for the second fraction, x divided by, open it up for the denominator, x minus 2, close it for the denominator, close it for the second fraction, close it for the first half, so that would be for the brackets, and then minus 1. Okay, we will then graph that function. And what you should see, even on a standard graph, it's going to look something like this. Oops, missed that one by a lot. Still missed it by a little bit. The goal is that you'll see that it's really right here. Okay, so we'll do second trace, 0. Left bound will be over here on this one. Right bound will be over here. And so you'll get a number that's like 1.197 e to the negative 14. Remember, when you have e to a negative whatever, however many numbers, that is essentially telling you that that number is 0. So our x will be 0 in our calculator, or we will choose x equals 0. And just to prove that we are right by making that making x equals 0 our answer, we would say we can put 0 in as all of our x's. So if that's a 0, that's a 0, that's a 0, this would be 2. If I simplify 2 over 0 plus 2 is 2, plus 0 over 0 minus 2 is negative 2, equals 1. That's gone. 2 divided by 2 is 1. 1 equals 1. So yes, it works. Okay, let's go ahead and look at the next one. So again, we're just practicing typing this into the calculator. So we're going to subtract 5 on both sides. So then we have x plus 2 over 1 minus 2x minus 5 equal to 0. Okay, we need to put this first part in parentheses. Specifically, the numerator and the denominator need to go in their own set of parentheses. So when I type this in, 1 for the first fraction in itself and then 1 for the numerator. As far as parentheses, x plus 2, close parentheses, divided by, in parentheses, 1 minus 2x, close parentheses for the denominator, close it for that part of the problem, then minus 5. If I graph that, I'll have something that's closer to this. And so we want to know what this value is right about there. So again, second trace, 0, left bound will be over here, right bound will be somewhere over there. And so we're going to get as an answer x equals 0.27 repeating. And that actually is our final answer. Okay. So guys, we are done with this lesson. This was a fairly lengthy lesson. But again, guys, if you have any questions, come see me for tutoring. All right.